you can listen to what we did, watch as I write on the board and stuff, and get the notes for that day. So if you're quarantined, I expect you to keep up. I've talked about this already, right? If you're gone on a quiz day, all right? I don't have my to-do here. Oh, that's what go back. If I go back to home, okay? I have to-do stuff or coming up, all right? If somebody submits a homework here, there will be a to-do list for me to grade some homework, all right? If you're at home, you're quarantined, day of a quiz, I expect you to do it that day, okay? It'll be under assignments, but it'll also be on the side here on your to-do list of what you have to do that day, okay? That's what happened, right, Olivia? It showed up, right? Okay. So, again, keep up. Don't put yourself in a hole. It's all there. Okay, you might have to wait till after this period so you can see what's going on in that, but you guys can handle it. All right. If you really need some extra help, email me. We'll figure something out. Okay, but we got to keep up. You don't want to not do anything in all your classes and then get so far behind you get yourself in a hole that you can't get out of. Okay. So let's get ready for tomorrow's quiz. Where's it at? Edit. There we go. Okay. So the first 5 of them you have to solve either by completing the square or just getting the square x squared alone, so you can take the square root of both sides. 6 and 7, real easy, complex conjugates, and then 8 is just 2 equations you got to solve. So I think it's a pretty easy quiz for you if you've been paying attention and doing what you're supposed to do. Okay, so as you can see, this one has no B in it, or the B value is 0. We got an A value of 4, C value, I put the 4 and 68 together, it'd be 72. Right? But there's no B, there's no X in the original problem. So you do not need to complete the square for this. You just need to get the X squared alone, so you can take the square root of both sides. So I'm going to add 4 first. So I have 4x squared equals 72, and then divide by 4 next, so it's just x squared equals, and what is it, 18, I think? Okay, at this point we can take the square root of both sides. Remember, when we do this step, we have to put plus or minus in front of our solution, our answer. Yes, Grace?
Is it okay to divide by 4 first?
That means you have to divide that 4 also by 4. Yeah, if you divide all 3 of them by 4, yeah, that would work. Okay, so this 18, we're supposed to put it in simplest radical form. Right? I don't want you to give me the 4.2 or 3, whatever it is, decimal answer. Okay, I want it in radical form. So the square root of 9 is 3, so the 3 comes out, and then the 2 will stay under the radical sign. So there's my 2 answers. Plus or minus 3 radical 2. Any questions? Okay, now if you look at 2, there's a little difference between 1 and 2. 2 has an x value, it has a b value, right? So it's not in the order right now that we want it, so we can complete the square. We need to take this negative 6x on the right and put it over with the x squared on the left. So we have to add 6x both sides to start. So we got the x squared plus 6x, And then we're gonna have to complete the squares, so we're gonna add our blanks. Remember, to add in the blank, and remember, it's always adding the blank, it's b value divided by 2 squared. So this b value is 6, divided by 2 is 3, and 3 squared makes it a 9 in our blank. So we made it one of those special trinomials, we call a perfect square trinomial. So you can factor it as a binomial squared, 2 terms squared. Remember that this a value to do this has to be 1. So it is in this problem, right? So we take the square root of x squared, the sign in front of the 6, which is addition this time, and the square root of 9. That's what goes in for my binomial. All right, and then add 27 and 9 and get 36. Now, basically, we're at the same point we were for number 1 when we got x squared alone. The squared part is alone, so I'm going to take the square root of both sides. Don't forget the plus or minus. The square root of something squared is itself, is what we say. So that's x plus 3, and we all know the square root of 36 is 6. That one came out nice, because it was a perfect square. So we subtract 3 to finish it up. Remember, there's 2 answers, and since these are both whole numbers, I expect you to find the 2 answers, okay? Negative 3 plus 6. Negative 3 minus 6. So 3 and negative 9 are the solutions to that quadratic equation. Questions? Making sense, hopefully. Good? Guys are quiet? All focused, right? Making sure we got this. Number 3. This one's got a 3x squared plus 12x equals 15. So I got my a and b on the left and my c on the right. That's what I want. But I can't complete the square until I do what? That's right. I got to make that a value a 1. Since there's a 3 there, I'm going to divide everything by 3. So I get x squared plus 4x. And then I'm going to add my blanks. And then 5. All right, so half of 4 is 2. And 2 squared is 4. For my blanks. So 9 on the right. And I get square root of x squared. There's addition in front of the 4 there, so plus, and the square root of 4 is 2. Now I'm at that point where I can take the square root, right? Pretty much repetition from here, right? So I got x plus 2 on the left, plus or minus 3 on the right. That's a nice number again, or the perfect square. Subtract 2. And since they're both whole numbers, I'm going to get my 2 answers. Negative 2 plus 3 is 1. Negative 2 minus 3, negative 5. Number 3. So again, that happens tomorrow on the quiz. Finish it up. You know, if that was negative 2 plus or minus the square root of 3, we could have left it like that. Okay? But it's nice when we get perfect squares in there. Questions? Again, we had to divide by 3 first so we could complete the square. Okay. Number Number 4 is like number 1. There's no x in it. So we don't have to complete the square. Okay, just get the x squared alone. So we're going to subtract the 100. Oops, getting ahead of myself. And then divide by the 2. So the x squared is alone. Remember, negative divided by positive is negative. Okay, so we got to remember this time, when we square root, is our plus or minus, all right? But since it's negative, we're going to have to pull out an I, right? And we got to simplify. 25 is a perfect square in there. So I can pull the 5 out for the 25, the I out because it's negative, and then the radical 2 will stay underneath. Simple, right? Questions? Don't forget about the imaginary unit when we have our negatives under the radical sign. Number 5, x squared minus 2x plus 9. Okay, those are both positive perfect squares, right? So it might already be one of those for me. Square root of x squared is x, square root of 9 is 3, multiplied 3x. Is 3x half of 2x? No, not, right? So it's not one of those. So we're going to have to take the 9 over so we can complete the square. So we're subtracting 9 over. Don't forget about that. Every year, we got somebody that forgets to make that negative when they move it. Half of 2 is 1, and 1 squared is 1. So when I factor it, square root of x squared, this time it's subtraction in front of the b. Square root of 1 is 1, and then negative 9 plus 1 is negative 8. Now back to what we always do, square root. And I get x minus, I don't need my parentheses doing. So I have x minus 1 plus or minus 4 times 2. 4 is a perfect square, so the 2 comes out because of the 4. I comes out because of the negative sign. And then again, 2 is left underneath. And then I just finish up by adding the 1. So it's 1 plus or minus 2 pi radical 2. You can leave it like that. There's still 2 answers. Those are complex conjugates, right? Stuff we got to figure out for 6 and 7. They always come in pairs like that. So we good on the first 5 solving, Grant?
The B or the next, like thing to get the blank.
Mm-hmm.
You wouldn't divide it by a negative 2?
No, you always divide b by 2. You know, so it'd be negative 2 divided by 2, which is negative 1. But what happens when you square negative 1? It's still a positive 1, right? So that's why it's always addition. Yeah. So even though there's a negative there in the b, when you square it, it still becomes positive. So that's why we always say plus blank. All right, any other questions? Okay. 6 and 7. Just finding the complex conjugate. Make sure it's in the right order first. Is this in the right order? Real part in the front, imaginary part in the back. That's the right order. Yes. Remember the I part's in the back. So then all you got to do is put put those same two terms and change the sign in between. So that's the complex conjugate. Now for number 7, it's not in the right order. It's backwards. So I would, first of all, write it in the correct order. So it's -7 plus 2i. You guys realize those are both the same, right? Okay, so then my complex conjugate is -7 minus 2i. Okay, so don't miss either one of those. I have to smack you upside the head. Garden. Okay, everybody. Questions? Okay, again, number 9 is simple, but some of us like to overthink it. Oh, 8. Well, that's tomorrow, you'll get a special one. A lot of you guys missed this too. Those of you that set it up right, but then you divided wrong. Okay, so real parts are in the front, imaginary parts are in the back, right? So the real parts are, if these two complex numbers are equal, then the real parts have to be equal. So those are the real parts. So those are equal. And you just solve it. What's 12 divided by 6? Okay. Imaginary parts. And again, you don't need the I part. Just the stuff in front of the eyes. They are equal. So it's -3 equals -15y. Now, a lot of you put 5 for the answer. That's not right. What are we dividing by? -15. Not dividing by -3. So that's actually 1/5 positive. Okay, so we should realize that. But a lot of you did 15 divided by 3 instead of 3 divided by 15. You got 0.2, that's okay, that decimal, that's all right. Is this that difficult?
No.
No, pretty easy, right? You guys have done a good job. So don't make those careless mistakes tomorrow, okay? And then make sure we show up Wednesday for some tangram fun. You'll see. I know, Olivia, you will like it. Okay, any questions? Okay, cool. Good job, as always.